Yep, so hello everyone and welcome to my talk, Beyond Cryptojacking, Studying Contemporary Malware in the Cloud. So as we've already said, my name is Matt Muir. So to give a bit of a background about me, I'm the Threat Research Lead at Kado Security. Prior to working at Kado, I was a macOS malware analyst for several years, and I've also got a bit of a background in digital forensics and DevOps engineering, Okay, so this is the agenda for today's talk. So the talk revolves around two different malware families that we've been recently tracking at Kado. So I'm going to kick off with a bit of an introduction and discuss some of the motivations behind doing the talk in the first place. Once I've done that, I'll move on to our first malware family of the day, which is called Legion. And Legion attempts to automate SMTP abuse in the cloud. After I've discussed Legion, I'll move on to P2P Infect, which is an emerging Rust botnet family with some interesting initial access techniques and specific targeting of Redis and so on. Finally, I'll wrap up with a little bit of a conclusion on and give you some tips for reverse engineering Rust malware if some of you happen to find yourself in the unfortunate position that you're actually doing this. Before giving you some trends and observations from this aspect of the security industry. Okay, so without further ado, let's have a think about why this talk is actually important. So it's probably common knowledge now that attackers are becoming well versed in cloud technologies and Linux, therefore, as a result. And what we've seen in a lot of the campaigns that we analyze at Kado is a particular emphasis on exploiting web-facing services that are typically deployed in cloud environments. Now, what do we mean by this? So we mean things like Docker, Jupyter, and Redis, of course. Now, one of the key points of this talk is that cryptojacking isn't the only objective for cloud-focused malware campaigns. So once we've discussed these malware families, hopefully you'll realize that cloud attackers actually have a variety of objectives. And this isn't to downplay the impact that cryptojacking has. Of course, there are very real concerns around what attackers do once they've got access to your environment besides cryptojacking. Okay, so with that out of the way, let's move on to our first malware family of today, which is Legion. So Legion is a cloud-focused hack tool written in the Python programming language. And what it does is it targets misconfigured web servers, for the purpose of extracting credentials to cloud-based SMTP services. And we'll discuss this in a bit further detail in the following slides. Now, one of the things that caught our eye about Legion was the inclusion of a lot of AWS-specific functionality, including an AWS-specific persistence mechanism. Now, thanks to the efforts of researchers from Aqua and Sentinel-1, we've actually discovered recently that Legion is a derivative of several other malware samples. So, for example, FBot and Androx Ghost. And this, with Androx Ghost in particular, CISA themselves recently released an advisory on this malware, which shares a lot of code reuse with the Legion sample that we're going to talk about today. So to give a bit of a background on how Legion is actually distributed, when we first encountered one of the main payloads for the malware, we managed to extract a Telegram group ID from the sample. And of course, we decided to access this group and see how it related to the campaign itself. So when we accessed the group, they had around 1,090 members, and it had been active since February 2021. Once we had a look at some of the messages that were being exchanged in the group, we identified a user that seemed to be promoting the malware heavily, who also happened to be the admin of the group itself, and they had the username Forza Tools. Now, from there, we actually identified a YouTube channel with this same name, which helpfully included a lot of tutorial videos for how to actually use Legion. So I've mentioned already that the malware attempts to extract SMTP credentials from misconfigured web servers. So on this slide, you can see a number of hard-coded paths that are included with the malware. And so what it will do is it will enumerate resources at these paths in an attempt to extract them and parse them for secrets for other cloud SMTP services. Now, as you can see here, it primarily targets web technologies such as Apache and Laravel. And in the case of Laravel, it will attempt to retrieve a .env environment file, which is occasionally used by developers to store secrets in order to avoid committing them to Git. So if it's successful in retrieving this, a series of regular expressions will be run over the contents in order to discover, in order to extract secrets for services that they might be interested in. So what you can see on screen here is a code example for how such an environment file might be parsed in order to try and extract AWS-specific secrets. So you can see here that the malware is hunting for two different environment variables with the names AWS Access Key ID and AWS Secret Access Key. Now, it's a fairly safe assumption to assume that credentials are going to be stored as the value to these environment variables, as this is common convention in AWS tutorials and sample code. Now, as you might imagine, the malware repeats this for other services that it's interested in, and we'll look at some of those in the coming slides. So yeah, here's a list of some of the services that Legion will target. So if anyone's familiar with these services, then you probably recognize that they're mainly concerned with SMTP, but there are also some payment platforms in there as well. So this, of course, fitted with our hypothesis that the objective is to hijack these services for the purposes of conducting mass spamming campaigns. So I mentioned already that Legion's got some interesting AWS-specific features, so let's have a look at some of those just now. So to give a brief overview of some of these features, the malware has the ability to scrape for and generate AWS credentials. It also has the ability to create a backdoored user for persistent access to AWS environments. And with this backdoored user in place, obviously it attempts to elevate privileges for the user so that it can interact with SES, which is Amazon's simple email service, or in other words, AWS's cloud SMTP service. The malware will actually create a malicious IAM group to which it attaches the administrator access managed policy, which might be slightly infamous to anyone here working in cloud security, before going on and actually interacting with the SES service itself. So let's have a look at some of this now. So what we can see on screen here is an AWS credential brute forcing function that's used by the malware in the event that it can't discover secrets from the environment file method that I mentioned previously. Now, before we go any further, I would like to stress that this is incredibly unlikely to work. I'm not going to attempt to calculate the probability of success for this method on stage, but yeah, you can imagine it would likely be fairly low. So what actually is going on here is the malware uses the AKIA prefix, which is a prefix used for long-lived credentials in AWS environments. So it will take that string and it will append to it a string of 16 randomly chosen alphanumeric characters. And of course, what you then end up with is something resembling a valid AWS access key ID. So as you can see on screen here, the malware then proceeds to do a similar process to generate something resembling an AWS secret access key itself, which then results in what looks like a valid credential pair. So I also spoke about briefly about an AWS specific persistence mechanism. So we can see an example of this on screen here. So what the malware will do is it will create a user named SES_Legion and attempt to insert this into the target account. Once this is inserted into the target account, the malware will tag that user with the key owner and a value of ms.boharris. And of course, this is a good detection opportunity for defenders. Now, at this point, I'd like to give a shout out to Ian Al from Permiso, who has done some interesting research into earlier variants of Legion. So he noted that in earlier variants, the malware doesn't actually carry out this tagging behavior. So if you encounter a user with SES_legion with no tags, likely you've been compromised by an earlier variant of the malware. So going forward, the malware then creates a malicious IAM group called SES admin group. And as I said before, it will assign the administrator access managed policy to this, which of course should ring alarm bells for those of you working in cloud security, as this essentially gives any users within the group complete access to all AWS services, including the management console, providing this has been enabled. And what you can see on screen here is an example of this function, which of course is named create new policy. So with all of this in place and with privileges elevated for the malicious user, the malware will then proceed to attempt to interact with the simple email service itself. And it does this by establishing a client using the AWS SDK for Python, which of course is known as Boto3. Now, in order to do this, you need to pass in a number of default parameters. So for example, like the region that you wish to use, and obviously the access ID and access key that we spoke about at the credential stage. So of course, all of this fits to make us, or to confirm our theory that Legion is primarily concerned with SMTP abuse. As once the operator has established all of these procedures, they can then, of course, proceed to send test emails and that sort of thing. So let's have a look at that just now. So shortly after establishing the SES client, the malware will then proceed to query the send quota in the account, which of course is the number of outbound emails that you're allowed to send. And this is valuable information to help the operator evade detection, because people might have alerts set up for things like quota violations and billing alerts, for example. The malware will then also proceed to list SES identities. So these are things like organizational email addresses and domains that are used to populate the sender field. And once it's done this, it will then proceed to send a test email with the results of some of its discovery operations to the operator themselves. So as you can imagine, if the operator receives this email, they now know that they have persistent access to AWS, and they can leverage SES to conduct mass spamming or even phishing campaigns and that sort of thing. So this is just a bit of a side note. I wanted to highlight this technique that we've seen with a number of malware campaigns recently. And that, of course, is the reporting of campaign statistics back to a Discord channel. So what happens in the case of Legion is the malware will populate a Discord embed, which is essentially a block of JSON, with some statistics, including the number of vulnerable sites discovered, the number of successful RCEs, and the total number of sites processed. This, of course, is then sent back to a Discord channel of the operator's choice via an HTTP post request, where it can be viewed in a centralized location. Now, why would malware developers attempt to use Discord in this manner? Well, of course, it's high availability, especially compared with some custom C2 infrastructure that you might have in place. But most likely, Discord is not restricted in your target environment. So depending on who you're targeting, of course, it seems unlikely that this outbound traffic to Discord would be prevented. Okay, so that just about covers Legion. So I wanted to move on to our second malware family of today, which is P2P Infect. So P2P Infect is a Rust botnet agent that we first discovered in July 2023. Now, P2P Infect was interesting to us as we discovered it after triaging some honeypot data, specifically around one of our Redis honeypots, which we know is often targeted by cloud-focused attackers. Now, of course, that tells us that the malware likely uses Redis for initial access, but not only that, we've since discovered that it can also target SSH servers for initial access as well. Now, one of the interesting aspects of P2P Infect is the fact that it has multiple evasion techniques. And obviously, as a malware analyst, this is a bit of a nightmare as it can hinder dynamic analysis. So the sample will actually also conduct internet-wide scanning in order to identify vulnerable Redis and SSH servers to infect. and we'll discuss that in a bit more detail. And finally, when we first discovered P2P infect, the samples that we looked at initially were compiled exclusively for the x64 architecture, but recent samples seem to be compiled for MIPS, which is kind of interesting because MIPS is used in in routers and embedded devices, which suggests some sort of diversification in the hosts that the malware is attempting to compromise. Okay, so just to give a bit of background on traffic that we've analyzed that we can attribute to the P2P infect botnet. So when we first started to analyze the malware's traffic, we dedicated an individual honeypot sensor to analyzing P2P infect specifically. And at that point in time, we noticed something like 3 initial access attempts per week. So this was in August of last year. This number actually grew steadily throughout August, and then we ended up at a point where we had something like 6 initial access attempts per week before moving into September, where in a single week we had over 3,000 initial access attempts, which of course is a fairly dramatic rise that you can see plotted in this graph here. Now, the only explanation for this is that, of course, the malware has been quite successful in compromising new nodes. So we'll have a look at this in a bit more detail. So I've spoken about initial access and how P2P infect targets Redis specifically. So let's discuss how it actually exploits Redis in order to gain a foothold in the system. So what the malware will do is it'll abuse a feature known as replication that's common in data stores like Redis. And it will use this feature to deliver a malicious module to a victim node. Now, Redis modules in legitimate use cases are used to extend the functionality of the database itself, so they can implement new data wrangling techniques and stuff like that for the actual data held in the data store. But in this case, the malware developers use this functionality to allow the attackers to run arbitrary shell commands on the Redis host, which of course is very bad. So you can see an example of this in the screenshot that I've got on the slide here. So the malicious module used by P2P infect is named system.exec. And you can see there's some inline bash code there, which basically retrieves the main P2P infect payload and executes it on the Redis host. So something interesting to note about this is Unit 42 posted an analysis of a similar malware campaign, of P2P infect itself, but a Windows variant of the malware. But they noted a different initial access mechanism, which leveraged a Lua sandbox escape vulnerability that was discovered in 2022. So it's interesting to note that there are 2 Redis-specific initial access techniques for this campaign. So in terms of the primary payload, let's have a look at some of the capabilities of it. So as you can imagine, the primary payload bundles the malicious Redis module that we are discussing so that the malware can self-propagate in a worm-like fashion. Now, as is expected for Linux malware, shortly after execution, the malware itself will update the SSH config and enable things like password authentication before inserting a malicious attacker-controlled key that can be used for persistent access to the host. Now, with a peer-to-peer botnet, you might be wondering how the malware knows which nodes to communicate when it's first executed. So if anyone is particularly eagle-eyed, you might have noticed a base64 encoded argument passed into the binary in the previous slide. So this is actually an encrypted and then base64 encoded node list that includes a number of static file servers that are likely to serve the main payload. Another interesting feature of the malware was the inclusion of an additional payload that we've named bash. And the reason we've called it bash is because when it's extracted from the main payload and executed, it results in a process name that you can see on screen here of -bash. And of course, this looks fairly benign in process listings if you're trying to figure out what exactly is going on your server. Now, the bash payload has a number of interesting features, one of which is to monitor the /proc subdirectories in Linux to try and restart the main payload if it's killed. And it also includes an update mechanism for the main payload. So if it receives a signal from the botnet that a new update is to be pushed out, it will kill the main binary, pull down this new payload, and then execute it. And finally, the bash payload also kills high I/O processes, so processes with high file system I/O in particular. And we determined that this was likely an evasion technique to avoid things like analysis or incident response tools that might collect artifacts from disk. So let's have a bit of a look about how the malware itself actually spreads. So common to other Linux campaigns, the malware will read bash history, SSH config, and known hosts in an attempt to extract IPs from these files in order to infect related hosts. And of course, it infects them using the techniques that we mentioned earlier with Redis. But in the case of SSH, the malware will scan a random/16 prefix for exposed SSH servers, which it will then attempt to infect using a brute force attack with some bundled credentials. Of course, if this is successful, it will then drop a copy of itself on this discovered host, which, as we know, is known as worming. So I touched briefly on some of the newer samples being compiled for the MIPS architecture. So these samples had a lot of similar functionality to the original samples that we discovered, but they included some additional evasion techniques that I personally hadn't seen before. So this was particularly interesting to us. So one of these techniques is the disabling of core dumps. So not long after the malware is executed, it will use the Linux resource limits feature to disable core dumps. And we determined that this was likely for anti-forensics purposes because information about the botnet or the malware's configuration, for example, could end up in a core dump from memory. Another potential reason for doing this is for preserving availability on target hosts. So I mentioned before that the MIPS devices are likely routers or other such embedded devices. These are often low power and don't have a lot of storage. So if the malware is excessively writing out core dumps, that could cause issues with availability. So moving on now, another interesting technique exhibited by the MIPS sample was the consultation of this tracer PID field that you can see in the screenshot on the slide here. So what the malware will do in attempt to evade debuggers and tracing tools is it will read the proc self status file, which basically contains metadata about the calling process. And yeah, you can see an example of that on screen. And it will check the value of this field tracer PID to determine whether it's non-zero. Now, if it is non-zero, that indicates to the malware that a debugger is attached or a tracing tool such as strace, and the malware will immediately exit. Now, this is something that there was some chat about online, especially in relation to Android malware, but it's not something that I had seen personally. So with all that in mind, you might be wondering what the actual objectives of P2P Infect are. Well, unfortunately, these currently aren't clear. So we've been running the malware in a controlled environment since we first discovered it. And we've yet to see it exhibit any functionality beyond the scanning and initial access mechanisms that I mentioned previously. So what we have managed to determine though is, or we managed to extract this botnet configuration from the malware's memory. And of course, you can see at the top there are two Unix timestamps, the bottom of which converts to a date time of the 31st of December, 2023 at 15:59:59. Now, we expected that this might be when the malware was likely to conduct some sort of attack, but unfortunately, it just continued scanning as normal. So a little note now on the size and composition of the botnet. So we're not actually sure who's behind the malware, but we're fairly certain that it originated in China, as there is a high concentration of infections in the Chinese area. And you can see the breakdown of this in the AS owner distribution chart that I've included on screen here. Now, that's not to say that the malware is restricted to China. We have observed infections in the US, the UK, Germany, and Singapore. So obviously, it's had success in compromising nodes across the globe. Now, in terms of the size of the botnet itself, our single analysis instance has communicated with 219 unique peers. which doesn't sound like a lot when you consider historic botnets, but it's worth pointing out that the malware uses a number of networking health metrics to determine closest peers. So the real number is likely far greater than this. So that covers our discussion about P2P Infect itself. So I'm just going to give some pointers about reverse engineering Rust malware, just in case any of you find yourself in this position. So Rust, similar to other modern compiled languages, stores strings as a contiguous blob. So unlike C-based languages, it has no null termination for strings, which can be a bit of a pain when doing static analysis. So strings are actually referenced in Rust using a struct with two members. The first member is a pointer to the first character of the string, and the second member is an integer defining the length. And yeah, as I said before, that's in common with Go binaries as well, if anyone's familiar with those. Now, currently, this isn't handled well by analysis tools, but fortunately, this is improving. So future versions of IDA, fortunately, will hopefully handle these a bit better. Another kind of annoying thing that Rust does is assigns a whole load of extraneous characters to function names, so internal function names. And that can be quite difficult to parse as a human being. So I've included an example of what I mean here on the slide. There have been some reports of this causing issues with function recognition engines, but I haven't personally experienced that. Obviously, this can slow down static analysis, but there are a couple of things you can do within your disassembler to try and make this a bit easier for you. But the main thing that I would recommend doing is just confirming that the function, you expect to see that particular function there based on surrounding logic. Okay, so that just about wraps up the talk. I'm just going to give you some trends and observations from the cloud security industry before we open up for some questions. So in conclusion, I hope I've made it clear that cloud and Linux threat actors are diversifying from what was once the common goal of cryptojacking. Now, the examples that I've provided, I hope illustrate this, but if they don't, then you can look at the fact that there's been a great rise in ransomware attacks on Linux over the past couple of years. So several high-profile ransomware families now have Linux-specific variants, which of course suggests that attackers targeting Linux have a wide variety of objectives. Another point I'd like to make is that, of course, botnet malware is still very much in fashion. Now, there are a number of reasons for this. Obviously, botnets are quite useful in DDoS hacktivism, and there's been a surge in DDoS hacktivism over the last 2 or 3 years in the wake of major global conflicts. So I wanted to also say that we'll continue to monitor P2P Infect and report on any additional functionality that we see in the hope that you can use this information to help defend your infrastructure from it. And finally, I would like to point out that I expect that we'll see more Rust malware samples going forward. So this is kind of reminiscent of the rise in the use of the Go programming language for malware that we saw around 5 years ago. Hopefully the tools will catch up, but if not, it gives us an interesting opportunity as researchers working in this area to create tools that aid in our analysis. Okay, so thanks very much to everyone for listening to my talk. So here are some references I'd like to leave you with. If you're interested in this area of the security industry, I would seriously recommend checking out these references. And also, if you'd like to keep up to date with our research, then feel free to follow me on Twitter at _MattMuir.
If you're in the room and you put a question into Slack, feel free to ask it here. That way you can put it in your own flavor and words. We've got a number of questions that have come in, so I'll just jump to that. But raise your hand if you got one. Actually, Becca had a question that made me think of something that Sierra said in her talk earlier. I don't know where she's in here right now, but talked about putting adversaries on the bench. It kind of ties back to Becca's question. You know, how has the P2P Infect changed since you kind of doxed it, basically? Have the actors changed anything?
Yeah, so the biggest change is obviously the targeting of the MIPS devices that I mentioned during the talk. In terms of raw functionality, the malware hasn't really changed that much, apart from implementing some additional evasion techniques. But we fully expect that this will change going forward, and that in fact what we are looking at is almost an early version of the campaign.
This is a general question, but how do you typically identify new families of cloud-based malware?
Oh, that's interesting. Well, yeah, obviously, kind of like traditional malware research, you would use a lot of open source intelligence. So if we discover a sample, one of the first things that we do is look at artifacts or indicators from the campaign itself and try and work out if anyone else has reported seeing those. So yeah, basically we rely on stuff that on open source intelligence that's already in the wild or being published by other researchers.
Any questions in the room? I've still got a number here on Slack as well. Okay, we'll go to the next one. We've got time for a couple more. Let's see. Question is, how to get an understanding on anomalous activities for a cloud instance versus a newly created cloud instance?
Interesting question. Well, I suppose you would probably have to establish a baseline in your monitoring, so you would have to have monitoring in place already, which always helps. So yeah, you'd probably have to set up monitoring in the cloud environment that you're talking about, and establish some kind of comparison or regular review of that monitoring, or set up some sort of alerts that help automate the identification of anomalous behavior.
Okay, let's do one more. This is a good one. With a small team, how would you suggest, and you're new to cloud research and things like that, don't have a lot of resources, what's a good way to start?
So I would start deploying some honeypots for some of the services that we mentioned previously. So a lot of our threat intelligence comes from our own custom honeypot infrastructure. If you're interested in that, actually, we have a really good blog on the Kado website about our specific techniques for deploying these services. So I would recommend that you check that out. But yeah, I would personally start honeypotting services that are known to be targeted by cloud attackers, reviewing the telemetry that those honeypots produce, and trying to identify patterns which haven't yet been reported in public reporting.
Well, I think with that one, let's go ahead and wrap up. I would, just since we're on the topic of Linux, again, we do have the workshop tomorrow. So if you want to sign up for that tomorrow afternoon, just go to the registration desk. And Matt, thank you very much.
Thank you.